Okay, thank you for joining me for this presentation about Arnold used in MaterialX. Yeah, there you go. So before we start, I have to show you this. So don't make any decision, especially buying decisions, based on this presentation, because some of the features are not shipped yet. So. Okay, so here's the agenda. So we're going to talk just a little bit about Arnold, and then I'm going to follow with USD and show you the latest on USD with Arnold, and then a MaterialX section, and we'll finish with some updates on Arnold itself. And hopefully we'll have some time for Q&A. All right, so. What is Arnold? I hope you know what Arnold is, but you know, it's a path tracer. It's been around for a long time. It's production proven, used in lots of studios and lots of shows today. And it works on CPU and GPU. We'll talk about this later. It ships by default with Maya and 3ds Max. And also we have plugins for other applications such as Houdini for the Katana. I have to show this to celebrate our ME, technical ME that we got last year. So we're happy about this. One specificity of Arnold that I'd like to highlight is our release pace. We like to do lots of releases and incremental releases. And as you can see, we vary feature releases and bug fix releases. So, but we try to aim for at least one release a month. Okay, so if something doesn't work in Arnold, the first thing we're going to ask you is to try it on the latest and greatest. Okay, and related like like you can see here, there's a trend of releasing bug fixes on USD. There's a lot of them in the releases. So let's switch to USD. So production ready, like everybody's doing USD. The reaching production readiness is really tricky, and I'll show you what we're doing in Arnold to try to achieve this. Well, first of all, if you didn't know, Arnold USD is completely open source. It's available on GitHub, and not only will you see the source code and everything and all the pull requests, but also you'll see the development process. So the entire development process on Arnold USD is open source. So you'll see our sprints, you'll see all the tickets, you see what's apologies. So you see what's going on in the sprint. So what is done, what is in progress, etc. And you also see our priorities for all the backlog we have. So this is open source. So I invite you to check this GitHub repo, post comments, post tickets, and help us define the priorities of what we need to do with Arnold USD. In a few words, what Arnold USD is USD extensions. So we have extensions to USD so that we can represent everything that Arnold can render, including the shaders. Because as you know, the shaders are not part of there's very few shaders that are part of the USD standard. But also we have specific shapes. One that comes to mind is volumes. Or implicit surfaces, things like that. Also, we have specific lights. We have also extensions to USD and extensions to Hydra. So Hydra, we'll talk more about Hydra, but Hydra is not USD. It's a way to render USD data, but other stuff also. And you have to have some extensions so that the Arnold specifics can be displayed in a viewport or can be rendered through Hydra. So there's many ways to consume USD for Arnold. The very straightforward way is to render USD files directly. So you can kick a USD file. We have, if you're familiar with AS file, the AS file format of Arnold, there's a 1-to-1 mapping between AS files and USD, with the exception that in the USD file you can select the frame that you want to render. So that means that everywhere you can export an AS file, you can export a USD file. So all of our plugins are able to export a render archive, and you can export a render archive in USD file format. And this USD file will contain all the extensions of Arnold, so it's ready to render. It has all the shaders, everything. Okay, so that's the first way to consume USD. Another way is to use USD as a procedural. So procedurals are objects that can import some geometry in a specific file format. So you have procedurals for the Alembic file format, for AS files and other file formats. So USD is yet another file format that you can ingest. What is cool about this is that it's a very common workflow to import geometry like this in Arnold, And so all the workflows that you have, for example, here in Maya, you will have the same in USD. So like loading this USD file in Maya, well, you can introspect, you can see the structure of the USD file, you can override anything, you can hide anything, you can assign a shader with operators, you can do everything that you would do with an Alembic file. And the third way to consume it is the Hydra render delegate. So if the application you're using has the Hydra delegate mechanism implemented, then you're going to take advantage. You're going to be able to take advantage of this in your application. So this is an example in Houdini. I want to take a few minutes of your time to explain this very basic concept, but very often misunderstood, that Hydra is not USD. Okay, I'm going to repeat this. Hydra is not USD. And this is why we're having trouble sometimes to match the render from Hydra and from USD. As I explained before, you can render USD directly for Arnold. That's the preferred way. As an engineer, you have USD translated to Arnold render. Perfect. One copy, one translation. That's the leanest path. But if you want to take advantage of a Hydra, because Hydra is good for interactivity. There's callbacks from whenever something changes in the scene, you can update the renderer. So that's what is cool about Hydra. But unfortunately, that means that you have to go through a different data model. You have to translate from USD to Hydra and Hydra to Arnold, which means that it's a completely different code path, and sometimes it's difficult to match for good and bad reasons. Sometimes it's a bug from our part, or sometimes there's something that is not Hydra, it's not designed for final frame rendering, and so we have to work around it. Okay, so it's not an excuse. We'll get there to have like full parity, but I just want to give this explanation on why sometimes, especially in Houdini Solaris, people expect everything to work because they know it's working in Arnold, but they don't see it in Hydra. That's why. Right, so Arnold USD is integrated in many applications. So it's integrated in Maya USD and in Bifrost. So where you can export Arnold-specific data from those applications. So meaning the specific shaders or shape properties. And also we have a shared USD stage between the Maya proxy shape and the Arnold procedural. That means that you can edit the USD stage live, and it will update in the render view. And we also have support for Bifrost USD. Of course, we support Houdini Solaris, which is one of the major actor for USD editing at the moment. And so this is where we are spending a lot of our resources at the moment, because there's a lot to do to reach production readiness. Okay, so this is not up to date, but I just want to illustrate how much we work on making USD production ready. And there's a lot to do. So this is what we've done up to July. I think it was, it's going into July. So lots of features were added so that they work in Hydra, work in Solaris. And it's things that you take for granted, like volume motion blur, I don't know, AOV shaders. The most infamous one was Cryptomat. Cryptomat was really tricky to implement because of the way Hydra is designed and how Arnold is designed. It was tricky, but it's there now. We also have actually in Houdini Solaris, I forgot to mention this. We now have a render path that doesn't go through Hydra, so you can render directly from the USD stage in Solaris directly to Arnold, which is helpful both for performance and for compatibility. Okay, still illustrating lots of USD feature were released. This is taken from the the release notes. Okay, I don't expect you to read all this, but yeah, there's lots of things just for USD and bug fixes also. Lots. Okay, so I'm going to repeat. It's rapidly changing. So yeah, if you hit a bug, try with the latest and greatest Houdini and Arnold, and if it still doesn't work, we will consider the bug, and we try to gather stats on like what's the most important thing in production. We work with several studios also to get the sense of the priorities. But yeah, we need your input. Yeah, so help us define the priorities. Okay, so what's next with Arnold and USD? So better Houdini UX, because we've figured out like the biggest chunks that were missing, but they're not presented in a very nice way to the user. So we're going to make it obvious for a user that you need to use this workflow if you want to have the best results, etc. So we're working on this. We're going to continue the integration in Maya USD and Bifrost, obviously. 3ds Max USD support is coming. That's a new thing in 3ds Max. I think it's in beta now. A big focus is MaterialX. I won't talk about this. We're going to address this later, but to have MaterialX in USD. Also things like core management in Hydra, many other things, operators, images in Hydra. Lots of things about Hydra. So, all right, not everything works yet, but there's hope. So, and we're very happy to present the work that Megalis, which is a Japanese animation studio, has done with this animated series for Netflix, entirely done in Houdini and Arnold with USD. And they started doing this 2 years ago. If you know the state it was in 2 years ago, it was very bold of them. And we thank them for that. They helped us a lot to define what was needed for production. Okay, and we continue to work with them. Right. I invite you to look at this YouTube video. So it's on the Autodesk channel in the Vision series, where the studio is describing the creative process, how they used USD, how they leverage the power of USD for their production, the problems they ran into. It's very interesting, and there's a large chunk that is devoted to the creative process. So yeah, have a look. All right, let's move to MaterialX. So, what is MaterialX? MaterialX is many things. Maybe it's one of the problems of MaterialX. So MaterialX, first of all, is a standard, right? And it's an open source standard that has been accepted as part of the Academy Software Foundation. Okay, so it's also a file format based on XML. It's also something that generates shaders. It's a shader generator, so you can describe materials and shading, but then this description is going to be used to generate the actual thing that is going to be rendered. And there's many generators, but the most prominent ones are OSL and GSL. And it's also a shader library. There's a standard set of utility shaders and a standards some sample material models. Okay, right. So it's the goal of MaterialX obviously is to exchange materials between renderers, between systems, between application, and you get the same result. Okay, everybody wants that, but this is not going to happen automatically. Okay, so I'll give you a word on the status of MaterialX. So it's rapidly evolving, and when I say rapidly, I talked about USD rapidly evolving. MaterialX is even more rapidly evolving. It's not set in stone. Like with with each version, there's lots of changes, right? I will demonstrate that Autodesk is heavily invested in MaterialX at many levels. I will just focus on the media and entertainment part of Autodesk, but Autodesk overall, you know, including CAD, construction, they're all interested in MaterialX. I also want to highlight that visual match is not guaranteed, but it's not a contract. There's a description that is open, but it's up to the implementations to have something that matches. I think something reasonable to aim for is, you know, 80 to 90%, right, in terms of visual fidelity. I'm sure it's going to converge, but that's the best you can hope at the moment, right? It's also missing lots of shaders out of the box. Like I said, there's some utility shaders that are standards, but it's missing very important ones that are not defined yet in the standard. So volumes, hair, car paint, and many others are not there, not defined. Okay. And one thing that is important for production color management is the support is incomplete. It's also rapidly evolving. We're addressing those issues, but it's not there. All this to say, don't rush in production, or if you do your homework. There are lots of caveats, okay? And also what is confusing is that Arnold has extensions to MaterialX to support the shaders that are not part of the standard, but there's no guarantee that they are going to be supported in another renderer. And equally, there's extensions to MaterialX for Karma in Houdini, and those are not guaranteed to work in others. Okay, so I mean, okay, just I hope you got the message that it's still very new and fresh. It's going to get there. We're 100% invested in it. We're strong believers, but you know, in production, especially if you're doing a big movie, just, you know, do your homework. All right, so now I'm going to present some things that were presented at the open source days at SIGGRAPH. This was an event of the Academy Software Foundation, and I invite you to look at the video of the entire event. There's lots of things in there, not just Arnold and Autodesk stuff, but also from other contributors, so it's very, very interesting. Have a look. But I'm going to just focus on the Autodesk and specifically the M&E part of it. All right, so I'm not going to go into details in this, but I just want to show you a sample of the involvement of Autodesk in MaterialX. So we've contributed many things, and those contributions are open source. They're merged into the repo. So there's an extension to display it on the web. There's a Vulkan shader generation, and this has been open source also. Okay, there's many more, but I just took this slide from the presentation. In Maya USD, MaterialX is also supported. So it's supported the latest and greatest MaterialX version, support for dome light, and other stuff also. There's also a very big, there's also a project at Autodesk, and I'm responsible for this project also. It's called LookDevX, which is a new material editor for Maya and other applications that supports MaterialX. It supports USD and through USD MaterialX. And it's actually in beta, in the Maya beta now. We also have been working on the material library based on the MaterialX file format. And lastly, let's focus on Arnold and the support for MaterialX in Arnold. So we were one of the first adopters of MaterialX. It's supported since 2018 in the form that it was there. There is you can ingest MaterialX in many ways in Arnold through an operator. That was the old way, but now we're trying to support, you know, shader generation on the fly so that you have more fluid workflows, and that's coming. The current focus, as I mentioned before, is really to integrate MaterialX in USD and support that through Maya USD, LookDevX, and Houdini. And this is MaterialX with Arnold in action with the chess scene that was contributed by side effects to the MaterialX repo. That's a great test scene, and this is the results we're getting. And now for something a bit more technical, but still, oh, this slide doesn't work, but I'm going to just show even more our involvement in the standard. And that's something that was demonstrated in the same meeting. You'll see it in the video. But that's actually some work on OSL and not MaterialX. But you'll see where I'm getting. So that was contributed by Adrien Rubel from our team and Chris Kula from Epic now. But Chris Kula used to work at Sony before on their Arnold. And so that's a joint collaboration to extend OSL with the closures, so that's the basic elements to define a shader that are compatible with, that will allow to generate standard surface. So, okay, so those are the closures. I won't go into details, but like those are the elements that you use to define a more complex shader, such as standard surface. So that's the layering model of standard surface. And so each of those layers is basically one of the closures that I showed before. And so now this has been normalized within OSL, and there's sample implementation for all of this, so that finally in OSL you can define standard surface, which is a complex shader, in just a few lines. So that's the implementation after the work that's been done. So this is really cool. That simplifies everything. That allows all the vendors to have like a good sample and a complete sample implementation of standard surface using OSL. And this is what in the future MaterialX is going to use to generate OSL. So that's what the renderers will have to ingest to have a representation. So, you know, yeah, we're invested everywhere to make this work, including changing foundational things in OSL. All right, that's it for the MaterialX section. I'm keeping track of time because I want to talk about everything. And let's move to the last section of this presentation, which is what's new in Arnold. So there's many things. I just picked a few things, and I'm going to flick through lots of slides. In like a while ago now, well, not well, maybe 2 years ago, we introduced a new framework to do 2D post processes in Arnold. So, and it's called images. So this is to do the things you do generally in Photoshop or in a compositing software, and like such as bloom, tone mapping, lens effects, this kind of stuff. We've added more of those little bricks recently. We have LUT, tone mapping, we have color curves, things like that. So, okay, that's the kind of thing you can do with images. But I don't want to talk too much about images. So you can do also light mixing. So render different light AOVs and mix them live after. Images are really interesting for denoising. So previously, denoisers were really integrated in Arnold, and it was a separate post process. And we've switched to converting all the denoising as an imager. So it's a 2D post process. You can apply it. You can see the result interactively. You can tweak the parameters interactively. That was the goal, to completely separate it from the renderer. And that allows us to integrate more denoisers. And we've integrated recently the Intel denoiser. And we have other denoisers, and it's a cool option that you want to try. If you're not using denoising, maybe you should start with this one, because it's like a general purpose, really nice, pretty fast denoiser that works everywhere. It runs on CPU. Okay, so that's before and after. It's really useful for interior rendering. it works really well for interior rendering, which is something that is difficult for Arnold to render. Okay, so we've improved the denoising recently, and if you've tried it before and you thought the results were not good enough, like try it again, especially because we've improved actually the albedo. But okay, this is the kind of results you got in Arnold 6. So I don't know if you can see, but in the middle of this kitchen, there's actually a thick glass pane, and everything that's behind it is blurred when you denoise it. And the reason is simple, because to drive the denoising, you use several utility passes, and one of these that is very important is the albedo, the color. And because the color was not coming through transparency, well, you didn't have anything to guide the denoising. And in Arnold 7, there's color, and the result is like this is the change, like from Arnold 6 to Arnold 7. You get really all the results. This is also useful for specula. So a common source of specularity is hair, and because if we didn't have any specular albedo coming through, hair was black, and thus it was very blurry. And now, because we have this albedo coming on from the hair, you see the denoiser is able to do a much better job. Okay, so this improves optics and Intel denoiser results. Okay, I think I'm going to skip that because I want to present other things. Yeah, this table is actually useful. So you see now we have 3 denoisers in Arnold. Maybe we'll have more, but this is like where they stand. So optics and Intel are AI accelerated, so that's very fast. The NVIDIA one works on GPU only, the Intel one on CPU. The Arnold denoiser is slower, but has production features and also the ability to be stable temporally, like within an animation. You can feed it the frames before and after, and that's useful. We expect that those like animation, stability in animation, and consistent AOV denoising are going to come in other denoisers. Its features are very much wanted. Consistent AOV denoising is important. This is the ability to denoise each AOV, but with the additional constraint that they add up to the beauty, because otherwise you lose detail. Actually, I should show you this. So I hope it comes through, but you are. This is without this feature, and this is with. And if you look closely, you're losing detail before if you don't have this additional constraint. Okay, I would add finally for the denoising bit that it's not just denoising that we've improved. We've improved interactivity overall. It's part of an interactivity and performance play, where we want to switch from this kind of walkthrough where in an interior scene you see absolutely nothing. It's just a mess with noise, to if you add everything together to something like this, where as soon as you can see what you're doing, you can navigate the scene, you can make decisions, and it converges very quickly, and you're able to iterate more. Okay. All right. If we have a bit of time, I'd like to talk a little bit about GPU. We've been working on GPU for a long while. Okay, thanks. Adding features and features and features, and catching up with CPU. We're finally at there's a few that are missing that we're working on, but less and less. And we are at a point where we were at a point where we can finally focus on performance and scalability, and I want to show you some results. So the worst offender for memory usage, on a GPU you don't have a lot of memory, is texture. So we worked with NVIDIA to fix this, and this fixes the time to first pixel because you just load the bits of textures that you need instead of loading all the texture up front, and the memory consumption goes way back. So this is cool. That's been in Arnold for a while. We've done something similar with volumes, with the integration of NanoVDB, again an NVIDIA collaboration with them, and we're able to drastically reduce the memory footprint of volumes and now compress it so that it's at the same level of the CPU compression. That's extremely important. Also, we're able to address polymesh compression. So this is, this has been improving. Those are pretty recent versions, and you see how much we've reduced the polygon memory. CPU is still a bit lower, but we're getting there, and we're actively working on this. I'm going to skip this just to show you, if you add everything together, that's the interactivity you're getting with GPU, so it's fairly smooth. Okay, we're also very happy to see things like this, tweets of people just using GPU randomly, not thinking about it, and it works most of the time. Yeah, like this also. So yeah, that's rendered on GPU. Well, this one is really cool. It was like a few days after the release, and yeah, rendered it in 2 minutes on GPU. Well, this one is interesting. It's not GPU actually; it's CPU, but with denoising, interactivity. So yeah, that was a theme for last year. Okay, I'm going to skip because I'm running short of time, and I would like to have some questions. I'm going to highlight some of the new things that were recently released in the latest Arnold. So we've done a few things to improve volume shading, so more creative choices. So we have dual lobe phase function, so you can do something that is both more realistic, but also you have more artistic choices. So you have 2 lobes of scattering. One forward, usually you do one forward scattering and one backward scattering, and you can mix and match them. Also, we've improved the emission, and especially the blackbody emission, so it's more physically correct, more physically correct, and out of the box. So this is what you had before, but you could work to make it look like this. Now it's just very simple. You'll get this out of the box. So the density will influence the blackbody emission, right? And this is more choices on the contrast for the blackbody. So overall, more creative control. Something cool to mention also is that we have now a V-Array scene converter in 3ds Max, because that's a very common use case. Like people have scenes in V-Array and they want to translate them. So it's a very configurable scene converter. You can tweak everything. It's not 100%. It's very difficult. But that's the kind of fidelity that we have now out of the box, and we test this with Evermotion scenes, which is a common use case. And lastly, I want to mention some improved viewport rendering in Maya. Okay, I'm finished. Do you have any questions? Oh yeah, sorry.
Good. Yeah. Thank you so much. Do you have any questions? Anybody?
On anything that was presented or not presented.
No.
So much sub-questions to ask. I can't even think.
Okay, pick one.
Yeah, well, my main question is like the stylization with the Arnold. How is it possible, and how is it hard for you to make a stylized art that looks like Mid-Journey? It's incredible. I'm just still baffled about it, but still thinking where can we still have the docs to learn it as fast as possible?
Oh, okay. Yeah. Well, that's a good question. So we try to post as many videos as possible, and especially with league rigs. Lee Griggs. Lee Griggs presented last year at CGA. He's our in-house artist. He does also tutorials on the Arnold YouTube channels. So he's doing, you know, those. He's the one who does like this or this.
What's his name?
Lee Griggs.
Greg's.
Griggs.
Okay. Greg's. Okay. Thank you. Thank you.
Yeah. So yeah, start with this. There's lots of tutorials for this. And if you're after stylized, meaning tune shading, so non-photorealistic, there's also.
Not necessarily tune shading, but more of a painting.
Oh, okay. Yes, there's some stuff also there. Yeah, we'll start there, and then you can ask support, and we can point you to some great videos on YouTube or material that we have. Thank you.
Anybody else? I do actually. I'm good. I'm actually a rookie in all of this, and I actually wanted to ask, how do we approach this? I mean, I can keep up with what you're talking about, but I don't know how to even attempt to start. I mean, I get lost in a simple hypershade, let alone anything else.
Okay.
I know the resources are on the site, and I do look at them, but would you even consider things like this entry-friendly, rookie-friendly?
Yes, that's a good point. That's something that generally at Autodesk we try to do. Like there's more like in-application tutorials to guide you. Even for Maya, there's a great interactive tutorial now in Maya that's like a game. So just to get you started, like around getting started around the viewport and stuff. So we're not. We considered using this for Arnold actually, but we didn't have the bandwidth to do it. It's another. Well, there's several axes. So more learning material, for sure. Sample scenes, videos and stuff, but also try to simplify the workflow so that you have like presets and also remove parameters, remove stuff so that the barrier of entry is lower. But it's never lasting process, and
You mentioned Lee Griggs. He was actually online in one of our panels, and he kind of gave like the similar answer to that question. He has a YouTube channel which is amazing, and he really goes step by step. But even like trying to recreate it was, I mean, it's scary. This is amazing, but it's scary at the same time.
Like if you like, sorry if it's a standard answer, but look at the docs. In the docs, in the beginning there's a section with tutorials, so you can follow the tutorials, and there are scenes in there, so you can just download the scene and tweak stuff, right? Also for all of Lee Griggs' tutorials, sometimes he has tutorials like this. He provides the scenes, so and then you can start from there, tweak, see how it's done. That's how I used to do it. Yeah, it's just getting a sample scene, tweaking, and then.
Is that how you got into it?
Well, yeah, like everyone. Yeah.
Oh yeah, that's just that simple. You just open up and try it. Are there any more questions? Oh, that's right. Oh, yep.
How much do you collaborate with other render engine developers? Sorry. For example, Renderman, I'm assuming that was the first one they used for USD since it was in Pixar in-house thing. Were there any solutions that they already did that were helpful to you when it comes to implementing them for Arnold?
So with other renderers, we collaborate through standards.
Mm-hmm.
So through USD, and that's the best. Everybody has some secret sauce, like the Renderman did not help us implement some stuff.
No, didn't mean it that way. Just.
But that's the perfect example. So USD is a great open collaboration platform, and we can converge. A lot of USD is modeled after Renderman, which is, to be honest, causing some issues for us, because it's just not like it's tailored for their architecture, but we're iterating, and also, they're aware that they need to, have different different models, and hopefully it's going to converge. But yeah, sometimes we have collaborations with renderers, including with the code. The Sony Arnold is a great example, obviously, because we share the same roots. They're completely different now. Well, not completely different, but they are different enough that it's impossible to take something and apply it to our Arnold directly. You have to work. But yeah, that happens. We have also collaborations that I would not discuss with other vendors on many things. Well, everybody wants to have a smooth experience for users, so that you can interchange, so you can share models. In studios, mostly, like, you're always sharing assets, so everybody wants this. And even within the studio, you're using different applications, so that's always something we try to improve.
Very interesting. Thank you.
Yeah, well, a great example also, it's not specifically your question, because it was about renderers, but we have a great collaboration with side effects. With side effects, because and with Maxon, and with the Foundry, to integrate Arnold in those products.
I don't know. Okay, the mic's still on. Cool. So I just want to actually extend on Fred's answer for how to learn. Most of these renderers today are physically based. Arnold is definitely a physically based renderer. So I think it's really important just to think, like, before you go twiddling all kinds of parameters and things like that, think about the real world. How would you like this thing in the real world? How would you make the materials? How do you want them to look? And kind of be predictive in your mind of when you make a tweak in a parameter, what are you expecting it to do? Because as you get better at that, you'll see you'll get very quickly to the result you're looking for. And then to Fred's point, take a scene that's unlit and untextured, or sort of unlooked at, and just kind of work on that to try to build it up to something that you're looking for. And you'll see, like, very quickly, because it's interactive, you'll really get that feel very quickly. And Arnold has been developed to be very simple. There's as few parameters as possible. They're all artist friendly. Like, they're parameters that make sense. Like, you see the name of the parameter and you know what it means intuitively. So that's really like a part of learning the renderer.
But it's still not intuitive enough. Yeah, there's too many parameters. We always want to remove some. It's tricky. It's tricky. Like, we were happy with the few parameters as possible.
Not to shade other renderers, but yeah, when I came to Arnold, I was like, okay, this actually makes sense this time.
Oh, cool. I was glad to hear.
Are there any other? Oh, I'm blind. Nope. Good. All right. Well, sir, thank you so much.
Thank you very much.
And thank you for staying this long.